Alrighty, let's join back together and continue on with our new unit, Unit 3, where we're looking at Lesson 3 together. We have been talking about using square roots and cube roots and how we use lots of different exponent rules. And so we've been looking at different values raised up to the second power or the third power. So we've been doing some, do I get to draw on my screen or not? Oh, there it is. We've been looking at things like x squared and x to the third power, square roots and cube roots so far. So these are kind of the places where we started with yesterday's lesson. And throughout this entire unit, we're just going to see how we can use different bases and we can change and look at some different kinds of exponents. So we're focusing a lot on the powers that we're using, our exponents. And so today we are really going to look at using fractions as an exponent. So instead of something to the second power, what it means to take something to the 1/2 power, or what it means to take something to the 1/5 power. So we can start using some fractions now in our exponent and how that's going to impact some of the information that we're working with. So by the end, we should be able to interpret what those fractional exponents mean. So start with me at lesson 3.1, the warm-up, where we're talking about things that are squared and cubed, and to find some solutions for these. I need to get out my new workbook on this one. On this page, I'd love for you to draw a couple of pictures. We're going to start thinking about what these look like visually. So we're going to draw a picture next to numbers 1 and 2, and I'd like you to draw this picture with me. We're going to draw a picture of the graph of what x squared would look like. An x squared graph is a parabola that goes right through the origin. And when we're trying to set it equal to some different values, we can picture what those different values would be. We've got our graph of x squared. If I were to graph 25, I would have a horizontal line here at 25. How many times does my blue line cross my x squared graph? Nice, 2 times, thanks. So because this crosses 2 times, I want to be on the lookout for 2 answers. And it looks like one of those answers is a positive x value. So if I were to follow that down, what is a positive number that when you multiply it by itself, we get to 25? 5. Beautiful. Now how about this other answer here that's a negative number? What negative number times itself equals 25? Negative 5. Nice. So our x could equal 5 or x could equal negative 5. In the same way, if we had something that was going to equal 7, it has 2 possible answers. I see one here and one there. Now, the square root of 7, I can't do evenly. So you guys might have been thinking like, oh, we can do the square root of 25, and that would equal 5, or negative 5. Square root of 7, I can't do evenly. So I'm just going to keep it as the square root of 7, and this one is z, So z could equal the square root of 7, or z could equal the negative square root of 7. Our parabola gives us two answers, so we need to be on the lookout for two different possible answers for that one. Now our cubed graph looks a little different. So draw this picture with me for numbers 3 and 4. That's not done very well. Let me try that again. Our cubed graph is kind of a S shape, a very lazy S shape that goes right through the origin. And so now when we graph something like it equaling a value at 8, it's only going to have a single answer. It only intersects the graph one time. So if I wanted to figure out what y to the third equaling 8 would have to be, I would need to take the cube root of it. This was, again, our idea yesterday. We have something like a volume of 8. I need to find the cube root of it. Remember that on our graphing calculators, that's in our math button. Number 4 will help me take the cube root of something. And if I want the cube root of 8 to undo something to the third power, I need to use the cube root. So something to the third power, to undo that, to get that opposite operation, I need a cube root to make that happen. So y equals 2. That is the only answer that it could be. Only one intersection point. And same thing up at 19. If I have a value way up here at 19, it's only going to hit the graph one time. If I try to do the cube root of 19, I think I'm going to come up with a decimal. Yep. So I'm just going to leave it as the cube root of 19. Keep it as that rational, with the radical, use that radical symbol if something doesn't make a nice even answer. And let me capture that thinking for our friends who aren't here today with us. And we're going to start using some of this information to see how it relates to fractional exponents, what they have to do with each other. That's weird. Must have hit something. Alrighty. So our next part isn't really that helpful. So I'm going to ask that we skip section 3.2. until we get to 3.3. and 3.4 are much more helpful in understanding what these fractional exponents do, and we just want to get to the part that we understand how we can rewrite these things. So our big idea here is a different way to rewrite and to undo something raised up to an exponent is to use a fractional exponent to make it happen. We just said that we had an x squared equaling 25, and you guys told me that x could equal 5 or x could equal negative 5. That's what we got from our warm-up. Let's use a calculator and see what it tells us about 25 to the 1/2 power. What does 1/2 power look like? So try it on your calculator with me, whatever kind of calculator that you have. Even a little pocket calculator can do this same thing.
What are we putting in?
We're going to see what we get when we have 25 and we raise it up to the power of, and I'm going to use parentheses, you should too. Anytime you have fractions, use parentheses, please. 25 raised up to the 1/2 power. Or you could put it in as 25 raised up to 0.5, like a decimal.
Because I'm going to do that because I don't know how to do the fraction.
That's just 1 divided by 2.
Oh.
That's all.
I thought you had to put something special.
Yeah, no. So I just had a 25 there, and I just open up parentheses so that it knows I want 1 divided by 2.
I see it.
Yeah. And it's telling me 5. $36 to the 1/2 power. Is 6. 49 to the 1/2 power is 7. Do you see how we can make a connection now about what a 1/2 power is looking like? 25 to the 1/2 power is 5. Here we were doing the square root of 25, and we were coming up with 5 and negative 5. 25 to the 1/2 power equals 5. Here's the rule that we're going to use to show that. That's because 25 to the 1/2 power, the way I can rewrite that, is the square root. It's the half power, or the square root of 25. In this way, instead of taking the square root of something to undo something squared, we saw that one way we could solve this is to square root x squared and to square root 25. A second way to solve it, though, is that if I took both sides to the 1/2 power, we had a rule from lesson 1. One of our rules in lesson 1 tells us that if we have a base to an exponent raised to another exponent, that we could multiply those two exponents together and write it as a single exponent. Using that idea here, if I take this x squared and I raise it to the 1/2 power, what I end up with is x to the 2 times 1/2. Well, what is twice of 1/2? I have a half and a half. It adds up to 1. We add up to a whole. So x to the first does the same thing as taking a square root where it undid, we square rooted x squared. It took us x to the first. So that square root of 25 has to equal 25 to the 1/2 power. They have to equal each other. So we're going to write a rule. Let's look at our other couple examples first and see what our rule is that we're going to actually add to our list of rules in lesson 1. In the same way for number 2, we could rewrite it as 15, and then using the fractional exponent, we could write it as the square root of 15. Now number 3 changes slightly. We have 8 to the 1/3 power. It's not to the 1/2 power anymore. It's the 1/3 power. Here's how that's going to change things. We saw in our warm-up that we could take the cube root of 8 to find that it equals 2. Here we can do the same thing. We would take the cube root of 8. So whatever that denominator is becomes the number in front of the radical. That root that we're looking for. And the cube root of 8 actually equals 2. So we're, again, just putting things in some equivalent values, equivalent formats, because we're going to start seeing how simpler formats will be easier for us to calculate. In the same way, 2 to the 1/3 power would be 2 under a third root radical, a cube root. So whatever the denominator is of a fractional exponent just becomes the root for our rational symbol. We want that radical symbol that's going to be showing us what that looks like. This is such an important and useful rule. We're going to add it to page 8. So please flip to your page 8 where we had the lesson 1 summary. All of our rules so far that we have been doing are on page 8 in our lesson 1 summary. We want to add this rule to it. Here's the rule that I'd like you to write down. That a base to any fractional exponent, 1 over m. Actually, we're going to do it to the n over m. So any fractional exponent, because we're not locked into always being over 1. B to the n over m. We can rewrite as the m root of b to the n power. The numerator is going to stay with the base. The numerator is going to stay as an exponent. The denominator of our exponent becomes the root of a radical symbol. So we're going to put that new rule into action. A fractional exponent we can just rewrite as a radical That's our whole big idea right there for lesson 3. So let's do some different matching going on. Nice. All right. So I see lots of rules that we're going to be using. We're going to make some matches in section 3.4. That's weird. I've got all my numbers off. All right. So 7 to the third power is telling us 7 times 7 times 7. If I go to a calculator and do 7 to the third power, I see 343. Let's make that first match. 7 to the third matches with 343. Now I'm going to stay with things that are a base of 7 and have something to do with a 3 up in the exponent. All right, because these values are all related to each other. 7 to the negative 3. We have a rule that tells us that a negative exponent pushes it down to a denominator and makes the exponent positive. So we can rewrite 7 to the negative third power as 1 over 7 to the third. That's a rule we've looked at previously. Also on page 8. Well, 7 to the third power we just said is 343. So 7 to the negative third has to connect with this fraction of 1 over 343. I'm going to stick still with my exponents that have to deal with 3's. So 7 to the 1/3 power. We just added a new rule, a big idea, that we can rewrite that as the third root of 7, the cube root of 7. Whatever's the denominator of a fraction becomes the root of a radical. So let's see, cube root of 7. Ooh, I see that one up there. We got a match going here with our cube root of 7. And the next one down is the same cube root of 7, but this time, do you see how it's got a negative in front of that fraction? We're now going to use both of these rules, the negative exponent rule and the fractional exponent rule. We'll have it, a negative exponent immediately makes it a fraction itself. 1 over 7 to the 1/3 power. And a fractional exponent then turns into a radical symbol. So we have 1 over the cube root of 7. So 2 big rules that we keep on using over and over here. A base to a negative exponent pushes that base and exponent down to a denominator. And now our new rule that we just learned, that a base to a fractional exponent, we can rewrite as a radical root of that base. All right, let's knock out the rest of these matches. We'll do it in the same way. What is 7 squared? 7 times 7.
14. Oh, you mean like 7 times 7?
Yeah.
I don't know off the top of my head.
Yeah, that's all right. Go for it. Use a
I thought you
calculator.
were saying 7 times 2 for a second.
Yeah.
49.
Nice.
So, you got the C right there.
Awesome. Perfect. So let's match that guy to 49. Let's stick with our 7s and 2s. All right. So Faith, how could you rewrite 7 to the negative 2? What would that look like? Nice to be a decimal. Nice. Did you do it on your calculator to see it? Awesome. All right. So that's another great way to go about it. We can type this into a calculator. 7 raised up to the negative 2, Faith is telling me, is a decimal. Now we just have to figure out what that matches. 1 over 49. Nice. So we could even check that if we know we have these matches going on. We can see that they are exactly equal to each other. Same decimal, same value. All that it did is took our 7 squared, 49, and pushed it down to a denominator because it's a negative 2 exponent. It pushes it down to a denominator of a fraction. Aiden, how about 7 to the 1/2 power?
1 over the square root of 7.
Alright, nice. So I like what you're thinking because you got that square root of 7 thing. Be careful because it's the negative one that you gave me the answer to.
Okay.
Because that negative pushes it down to a denominator. 1 over the square root of 7. Here we're just looking at it just being a fractional exponent. It's a positive exponent. It would just be the square root of 7. So you're using both of those rules at once. Nice. So you kind of gave me 2 answers. The next one down is just our square root of 7. And then our 7 to the negative 1/2 matches our 1 over the square root of 7. Now we just have some great matches to make without any fractional exponents anymore. 7 to the first power just means 7. So 7 to the negative first power makes it into a fraction. 1 over 7. And then last but not least, anything to the 0 power, of course, equals 1. So we could make that connection too. So we're using some sets of rules. We can start using them in conjunction with each other. So if we have negative fractional exponents, we're just going to follow both of our rules. The negative pushes it down to a denominator. The fraction turns it into a radical symbol. Look at this. We're going to finish early. I love it. This is what I was hoping for. All right. Let's take a look at our cool down packet. Let's cool down lessons 2 and 3 that we looked at yesterday and today. I'm going to ask you guys to do your very best on cool down 2 and 3 independently. This is our check for understanding. Feel free to have your workbook open, look back at some examples of these. But I'll give you just a couple minutes to write down your best answers, and then we'll check in with some students to see what they wrote down. Please be ready with cool down 2 and cool down 3. I'm going to cycle around. Let me know if I can help you. If you guys have a question, drop it in the chat. All right, just a couple minutes, but hopefully that's enough to at least get you started and thinking about it. Miranda, would you kick us off, please? And I will give you your choice. Would you like to answer number 1 or number 2 for our cool down number 2?
I was gonna do number 1, but I'm not exactly sure for
Okay.
either one of them.
All right, well, give us your best idea about number 1.
I don't even know. I don't know what it means. What it means exactly.
Let's see if putting it into a different number would change it. What if I had something like the square root of 25? So this was something we looked in our warm-up today about what it was. Do you remember what the square root of 25 is from our warm-up?
Five?
Yeah, perfect. So another way to think about that is that 5 squared equals 25. So when we're looking for a square root, and I love that we can make maybe some connections to some more solid numbers that are more familiar. When we take the square root of 25, we're looking for what number times itself can get us to that 25. So that's what that radical symbol is telling us. The square root means what number times itself equals 7. That's kind of what that radical symbol means. We could also think about it in terms of our square that we were looking at the beginning of lesson 2 there. If we had an area of 7, what would the side length of the square be? But we're looking at what number times itself equals 7. Nice. Thanks for working with us through that, Miranda. I appreciate it. Micaiah, how about you? Would you help us out with either number 2 for cool down 2 or either of the ones from cool down 3? Which one would you like to tackle with us?
For cool down 2, I got 14 for the closest because it was a decimal number afterward.
Okay. All right. So you did the cube root of 22?
Yeah.
And you're saying you got 14 for that? Should be a little bit smaller of a number. I'm trying to think about how you would have gotten to 14. Can you tell me how you typed that in on a calculator?
Well, on the calculator, it showed it was like 3 times squared root.
Oh, I gotcha. I gotcha. All right. So we'll have to pick this up because it should be a much smaller.
Good morning, Rockets. This is Mrs. Wells with your student news. Attention seniors. A reminder, your
So we'll pick that up
graduation
tomorrow,
product,
okay?
caps, gowns, tassels, will be delivered today,
Sometimes let me type something in the chat
12:30 to
for you at home.
1:30 p.m. in trophy